Okay, so last time we stopped our discussion with list, how to define and create list in Erlang, right? So just to give you an overview of what is list, it's a data type basically, which is denoted by square brackets, and the list and tuples that we have seen are very similar, but tuple can be only used in a comparison, whereas list can allow a wide variety of manipulation operations to be performed, and we have seen some of the operations on that. So I'll also, maybe on Friday, I'll give you a hands-on demonstration of some of the commands in Erlang. Okay, so this was what we were talking about list. So just this is one example which is given in C language. Okay, you have to double each element of the list. So the function written in C language is double integer of x, integer n, int I for I is equal to 0, I less than n, I plus plus, and whatever is the array. X is an array here. So the ith element of the array is multiplied by 2, means it is doubling each element of the list. So I want you to write the similar function. I have given the C code to you. In Erlang, how will this function be interpreted as? So I'll pause for 5 minutes. I want you to give me the solution for this. A simple solution. It's a very simple solution. Try writing it. The C code is to double each element of the array. So instead of an array, we are going to have a list. A very straightforward solution for this. So first clause is you're doubling an empty list. So the name of the module is doubling, and it's an empty list first, and then doubling head or tail. So you're dividing the list as head and tail. And what you do for every element of the head, you just multiply it by 2. And you call the same function for doubling of tail. So it will go on in indirect way, it will go on calling it as a recursive call, and it will go on doing this till the tail has a single element. So these are the two clauses that is given. Now suppose we want to write a function. Given a list L, it returns a new list containing only the elements of L greater than 10. So a list is given and it returns a new list containing elements of L greater than 10. So that list may contain any numbers, and you have to just select the ones which are greater than 10. Can you write a clause for this? Think of writing it. Now we are making use of list, so try to use the functionalities of list. And a hint here is we need to make use of the guard. done? Can you give me at least 1 or 2 classes for doing this? Anybody? Okay. See. So filter, I have given the module name is filter. This is the first class for an empty list. And then what I am doing is I am using this same clause for and dividing the list into head and tail. And when head is greater than 10, that head will come out. And you are applying the same logic to filter of tail. So this is the guard that we are using when head is greater than 10. So if the head is greater than 10, you are separating out the head. Right? And similarly, filter head tail, and you're giving a recursive, you're giving a call to filter of tail again. So this or this. So this semicolon, there's a semicolon here, right? There's no full stop. So this is also a semicolon. This or this or this. And you stop. How many of you have installed Erlang? Have you installed Erlang? Because you need to practice all these small codes.
Yes, ma'am.
Yes? All have installed? What about the others? How many found a problem in installing Erlang? What about the others? Only one person is replying. So at this rate, then maybe next week I'll take a test on Erlang. I want everybody to install. If you have not installed, install Erlang. It's very easy. It just takes 2 minutes to install. Install it and try all these commands that I am teaching you. Is this fine? Okay, so we move on to the assignment operator. So we know that equal to sign is usually used as assignment operator, right? So in classical programming languages, Erlang supports all the variables and they can be assigned by using the equal to symbol, which is nothing but a match. So just as in mathematics, the equal to symbol does not mean assignment, but the LHS and the RHS are the same, that is equal. So if a is equal to 3, here is an example. If a is equal to 3, variable a has not assigned before, it is unbound and the statement succeeds by assigning 3 to a. So if this variable a was not earlier given some other variable, because we have seen that once a value is given to a variable, it is bound by that variable. So if this if this variable was previously unbound, it will successfully assign this 3 to a. A is equal to a plus 1. Now you know that a is bounded. Now a has a value of 3. So now here if you are trying to change the value of a, what will happen? So this statement will have the meaning that 3 is equal to 3 plus 1. You just put the value of a as 3 here, which is false. This means that 3 is equal to 4. So this is how Erlang is going to treat, and it will give you some exception error. So the statement above thus generates a bad match exception. So it's an exception error. So a bound variable cannot be thus reused as in classical imperative languages. So imperative languages like C, C++, Python, Java. So Erlang is but a bit different. So you try to understand this concept of if a variable is already bound, then you can't change its value. Okay. So and the reason for this is the symbol equal has its own mathematical meaning, that is equal to, and this semantic makes pattern matching very easy. So basically equal to is generally used for pattern matching. Now suppose for example you want to ensure that the first two elements of the list are same. So how do you ensure this? H, comma, H or T. So first element and this first element will means it is the same. So that is equal to my list. So how to ensure that they are same or they are equal? So we are trying to make use of this assignment operator. So now the list member function. Now this matching is very useful. It is a very useful in function class heads. Okay, when we are using heads or tails. In the previous example we tried to use heads. So let's implement a function which checks if an element belongs to the list. So I want you to go through these 3 lines of code. It is just you are implementing a function. So we are calling it as a member function which checks if an element belongs to the list. So just see and try to understand whether you are understanding these 3 clauses that are written here. And each and every line of code that is written on these slides that we have started from Monday are to be implemented. Okay, you have to check and see whether you can implement this in Erlang. The first clause is very straightforward. Member, you are checking whether X is a member of this list, but if the list is empty, it's going to return false. Then member X, if X is found, okay, and the tail, you're separating out the remaining elements here as tail, and this is the head. So if X is found here, then you're going to return true. Or if member of X comma head or tail, then you're calling this, giving a recursive call to member X of tail. So this is a way of writing the function which checks if an element belongs to the list. Now suppose you want to revise this code, you can write it in an efficient way. So how do we write this in an efficient way? Using a underscore symbol, which means a don't care symbol. So if it's an empty list, then you don't care whether that X is there, so it is just false, right? Now if the X is found at the head position itself, then you don't bother about the remaining elements of the tail. So that is don't care about the tail, it returns true. Or if it is not found in the initial head position, then you are checking for the tail. So these are the 3 clauses here. I hope these things are clear here. So these are the various data types that are generally used in Erlang: integers, reals, atoms, tuples, and lists. Integers, that are big int, that is integers with no limit, very huge integers. We are not talking about very small integers which just take up few bytes in memory, but we are talking about very big integers where there are no limits to the integers. Then they are called as integers. Then reals are floating point numbers or float values. Atoms, they are symbolic constants. Symbolic constants like, for example, we'll just compare this with C language. In C language, we write hash defined statements, right? Hash defined pi is equal to 3.14 something something. So we define the value of pi. So these are symbolic constants. Or you define hash defined true is equal to 1. Hash defined false is equal to 0. So all these symbolic constants are nothing but atoms in Erlang. So they are made of literals which start with a lowercase letters. So all these strings, all these are lowercase letters. And this is, see, it's beginning with a lowercase letter. So it has to begin with a lowercase letter. So these are atomic entities, and even if they are literals, they cannot be treated as classical C or Java strings. Right? So symbolic constants have a very different meaning in case of Erlang. Tuples, ordered sequences of elements representing a structured data. So tuples are in curly braces. We have seen that. So it could be anything. It could be strings, it could be integers, it could be float values, all combination. It's a mixed type. So the number of elements is fixed at the creation time and cannot be changed. So keep this in mind. So these are something like C structs. If you have used structs in C, the number of elements is fixed, which is determined at the creation time. And finally, we have list. Okay. Now let's talk about tail recursion. So we have seen the factorial code. We have already written this code. Fact of 0 is 1 and fact of n is n into fact of n minus 1. Now this we had seen that this code that we had written had some problem. Can you recall what was the problem? On Monday we had written this factorial code and I said that it has, if you write just these two clauses, it has some problems. What is that problem? Nobody remembers what we talked about? So you can find out from Monday's lecture. If you're just blankly coming for the lectures, then it is very difficult because this is all lectures are interlinked. So in this case, the problem of recursion, this is a recursive call here, right? So the problem of recursive call here is whenever there is a recursion, the function sits on the stack. So every time it calls a recursive function, it is going on piling up the stack. So this because of this, the stack size grows to a large amount and lot of memory is also being used. So in order to avoid this, we have tail recursion. So tail recursion and accumulators can be used. So fact of n is just called factorial with that number n and 1. Fact of 0 accumulator, you storing some value in the accumulator and just calling this n value with the accumulator, and we'll call it as accumulator 1, which is nothing but accumulator into n, fact of n minus 1 comma accumulator of 1. What is this? Can you tell me what is this? So we'll see this each line by line what it is. Okay. Now if the last statement of the clause is a recursive call, here you can see that this is a recursive call. And the recursive call is not included in the mathematical expression, then the function is tail recursive and the recursion is not performed using a subroutine call but a goto. That is, it always uses the same activation frame. Same activation frame, the meaning of same activation frame is when a recursive call is placed onto the stack, next time when that function is called, it uses that same stack space or the same frame of the stack. It does not change. Maybe this is too internal to understand how the stack is handled in Erlang, or in order to make the best use of the memory for stack, they are using tail recursion here. So this is if there is a recursive call and the recursive call is not there in the mathematical expression. We have written the mathematical expression for factorial. Okay. And suppose you write an expression which does not contain a recursive call there, then you can say that the function is tail recursive and the recursion is not performed using a subroutine call. So are you understanding the meaning of subroutine call? Like suppose I have a subroutine, I have some module written for finding the factorial, and then inside that module I'm calling another factorial function. Inside that I'm calling another factorial function. So it becomes a subroutine call. So it is not subroutine, but it directly goes to that same function, and that is why it is using the maximum use of that activation frame. The same activation frame is used because it is calling the same function. It is not calling a subroutine. So summing the list elements with tail recursion. So if you write this type, so try to understand what is tail recursive and what is non-tail recursive. So sum, this is the first clause, is equal to head plus sum of tail. We are just calling this on sum of tail. But if you are trying to make use of accumulators, okay, so this is same like the previous one, this accumulator, then this becomes a tail recursive. This is a tail recursive function. Okay, so I think before we continue with the different types of codes or different concepts of Erlang, before that we should understand. Let's try and do some hands-on so that things become clear to you. So I'll just switch to the Erlang shell. If you have installed Erlang, you'll understand it. So I'm switching to the Erlang shell. Just a minute. Yeah, is the screen visible?
Yes,
Yes.
ma'am.
Okay. So to start with the basic command line commands using in the Erlang shell. So this is the Erlang shell. Okay. So let's try and use some commands, some mathematical expressions. So if I use, so I'm just doing addition of two numbers. So this is the way you write it: 3 plus 5 dot. So is this like the corner element is not visible properly? Is it, can you see this properly? So 3 plus 5 dot is, so you have to terminate every sentence with a dot. So that is 3 plus 5 is 10. 8, sorry. So some any mathematical expression. So you can give any mathematical expression or some complicated expression. Suppose 3 plus 4 plus 2 and I want to multiply it by suppose 9 and put a full stop. So 6 into 9. So it will give you this. If you want to add float values, suppose it is 4.5 plus 8. Got the dot, so that gives you 12.7. And if it is floats expressed using exponents, so that also can be done. 10 plus 9, suppose this is exponent, minus 2, that is something raised to 2, and plus 4.5 and the dot. So this gives you 4.609. So this is basically working with expressions. And then you have using atoms. Like how do you define these atoms? So I told you that they are static. Atoms are static or constant literals. Okay, atoms, like suppose I want to give x, y, z dot. So this is an atom. So it's all small case. So atoms are generally used in the same way as you use the hash define statements in C. So that is the best method to specify or identify a particular value. And atoms have to start with a lowercase character, or you can delimit with single quotes as well. Suppose you want to compare, if you want to compare integers to get a Boolean atom, so we can say if 1 equal to 1. So this is comparing. I am comparing the two values, one on the left hand side, one on the right hand side. So if it is true, it returns true, or if it is false, it will return false. So this is how the comparison can take place. So how do you compare the, now we have defined one atom already, xyz. So let's compare and see whether this is equal to ABC, full stop. So it is false. But if I say a xyz equal to xyz full stop, it gives you true, right? And atoms basically are ordered lexically. Lexically in the sense, like suppose I want to say if A is less than Z, full stop. So if A is less than Z, it should give me answer is true. So it will not check whether Z is greater than E. It is going to check whether A is less than Z dot. So suppose you have it, this is 10 is greater than 5 dot or 6 dot. So right, 10 is greater than 6. So it is comparing from the left hand side, left to right. So it is ordered lexically. That is what we call it as lexical. And standard Boolean operators are also used, like and, or, XOR, not. And you can also use the is Boolean function to check whether the supplied value is true or false. So is underscore Boolean and bracket, it's a function, so use the round brackets. So this is atoms. Tuples are generally called as composite data types, and they are used to store collection of items. That is why we use the tuples, and they are delimited by curly brackets. So for example, I want to define a tuple ABC, comma DEF, comma, and I have another nested tuple here, comma GHI. So I have defined this. So 4 elements in the tuple. So this is how you define the tuple. So the contents of the tuples do not all have to be of the same type. But one special construct is of a tuple where the first value is an atom. So in this case, the first atom is called a tag. And this kind can be used to identify or classify the contents. So this is how it is used. For example, the tuple where the first value is an atom. So you can write it as tuples in curly brackets. So curly bracket, I say it is email. So email is a atom now here, and I will write some mail ID here. Suppose so this is the mail ID in single quotes, curly bracket complete, and dot. So this is how like the first atom is called as a tag, and this can be used to identify or classify. So this is email. So I have used this as an email, and this is telling me that this identification is that this whatever follows is a mail ID. So here the tag is email, and the tag can be used to help identify the remainder of the content in the tuple. Now these tuples are very useful for containing defined elements and describing different complex data structures. And Erlang allows you to set and get values in the tuple explicitly. So you can use these keywords called as set and get. Now setting and getting values in the tuple explicitly using the following commands. Now for example, I say element e comma abc comma def comma so this is what I have defined. So what this will do? Can you understand what it has done? Get, it is setting and getting. Element third. So from the tuple, third element is extracted. ABC is the first, DEF is the second, GHI is the third one. So it gives you the third element. Element 3, comma from this tuple. Right? Now if I use set element, set element, and in bracket I say 3 comma ABC GHI JKL. So this is one list, okay, and the next element is MNO. So I want to set this. Did you get? Set element. This I am using the term set element, and get element is just element. So it is not GET element, but it is just element, and you just give the position of that element. And in this third element, set element, in this set element I am setting the location as 3. So this MNO string has to be inserted at the third location. So it's replacing it, right? So it removes GHI and it sets this value here. So these are the two functions that are basically used for setting and getting values in the tuple explicitly. Then comparing the tuples, like you can entirely compare the two tuples. For example, ABC comma DEF. So one tuple is ABCDEF and the other tuple is ABC comma DEF. So I'm just checking for equality here. So it obviously it has to return this as true value, right? And if I check this other tuple, so it will give me a false value. Okay. Now for list, yeah, we have done a lot of examples on list. So let's try and use this list. This is the last data type in Erlang called as list, denoted by square brackets. List and tuples are similar, but whereas a tuple can only be used in a comparison, list has variety of operations that can be performed on that. So basic list is, let's write the basic list. So I have 1, 2, 3, ABC, DEF, GHI, and one more nested list. This is the list that we have defined. Now these strings are actually special type of lists. Okay, Erlang does not support the idea of string directly. So although you can use a double quoted value to create a string value. For example, if you can just write this as this becomes a string using double quotes. But a string is actually just a list of ASCII integer values. because every time when you're representing even a character, it is represented using the ASCII character. So the above string is going to be stored as a list of ASCII characters. So now suppose if we write the ASCII characters, like suppose if I write this as hello, okay. If you write the ASCII characters for H, E, L, L, O, then you should be able to retrieve the string back as a hello. So it should give you that. So suppose I mention this as list. So ASCII value of capital H is 72. For small e is 101. Then L is 108, 108, and O is 111. So I've written the list for hello. So it should give me the string back. So even if you write the string in double quotes as hello, it gives you it is written as the ASCII characters. So that is the thing that it does. Then specifying the characters using, suppose I want to use dollar character notation, so that also can be done. For example, I'll write as hello character H comma character E comma sorry dollar. It is dollar E comma dollar L comma dollar L comma dollar O. So you can specify this also. So you can write it in this way, or so these are different ways of writing it, right? So either you write it using double quotes, or you can just precede every character by a dollar. It gives you the same answer. So either you write this or you write it this way, it gives you the same. So it is just specifying the characters using the dollar character. So list including strings or list of characters support a number of different methods for manipulation. And this is the main difference between a string and an atom. Atoms are static identifiers, but you can manipulate a string by examining the components part. That is each character. Component part means each character of the string. Okay. For example, if you want to identify the individual words in the atom, because when you write it as an atom, even if it is a string, like suppose I am a student of PUCSD and I write it in single quotes. So this atom is considered as a single entity, but a string can be split into different words, right? So if it so this entire statement that I am a student of PUCSD becomes a atom, which is considered as a single entity. But in a string, it can be split up, like I will be one word, am will be one word, student will be one word, and so on. So it will be a string will be split into different words. Okay, and there are different functions which we will see for manipulation of this. For example, a short function which we can use is specifying the module and function name. For example, lists and the function name is sort. Suppose I just want to sort, and what are you sorting? Suppose I want to sort 4 comma 5 comma 3 comma 2 comma 1. These are the elements that I want to sort. So, and what is the module name? Module is list, and the function name is sort, and a full stop. So it will sort. So what is a module name? Module name is list, function name is sort, and I'm just giving a list of numbers to sort. It sorts that number. So this is specifying the module and the function name. The list manipulation, you can construct lists with multiple elements using the constructor. So since all of you are aware of what is a constructor, so you can construct lists with multiple elements using the constructor, which builds a list from an element and another list. So it will build the list using an element and another list. Okay, this kind of construction is handled by functions or operators for push. If you have seen the push and pop functions, so the push function handles this type of manipulation. Okay, and in Erlang you use the pipe operator to differentiate between the head, that is the start of the list, and the tail, which is the end of the list. So that is what we had seen in the examples. With square bracket we have head, pipe sign, and the tail. So here the head is basically a single element and tail will contain a list of elements. Okay. Now suppose you want to add a new value to the beginning of the list. You have some list already and you want to add a value to the beginning of the list. So you can just write it as, suppose I want to add one pipe sign and already I have a list with 2, 3. So what does this mean? This means that I'm adding 1 to the beginning of the list. So that is why I have put it in the head position and the remaining part of the list is 2, 3. So this is a list that we get. And you can repeat this for the entire list. For example, like even if it is a blank list, or you can have, if you want to just separate out this. So I'll just show you how this is written. You can repeat this for the entire list. Like 1 pipe sign, 2 pipe sign, 3 pipe sign, and empty. And after that, and then close 1, 1, 2, 3. I hope the number of brackets are correct. Yes. So either this or that, like this is the way you can write, or you can just pipe it and you can have individual elements, and then you have to terminate it with a empty list. So that ends the, so it gives you the same answer. It is just another way of writing this. Now constructing a nested list. So how do we construct a nested list? So suppose I have 1, 2 as one list, right? And I want to pipe it to another list. Suppose it is 2, 3. So you have 1, 2 piping it to 2, 3. So what it will give you, what answer it will give you? So this is the way it is given. So what it is doing is, this is one list already and the second element is 2 and the third element is 3. So this is how it will construct a nested list. So it is a list within list. So 1, 2 is a list within this list. Nested list. Now suppose you want to merge the list. I want to merge two lists. So we have the plus plus operator which does this. For example, 1, 2, and I want to merge it with, suppose 3, 4. So what it will merge the two lists. So plus plus is the operator for merging. Suppose you want to subtract. You can perform subtraction also on the list. 1, 2, 3, 4. And I want to subtract, so minus minus, I want to subtract 2, 4. It will remove 2, 4 from the list. So it is minus minus. So plus plus is for merging and minus minus is for subtracting. Okay. And the same, these plus plus merging operator and this deletion operation. The plus plus and minus minus operators can also be used on strings. Tanuja, please switch off, mute. Okay. So let's use the same operators plus plus and minus minus on. So I'm just merging these two strings. So let's see how it will merge. So it is doing hello and good morning. So there's no space in between. So if you want a space in between, then you can, let's add a space here and see if this works. So this is how you do. So even the plus plus operator works with lists as well as it works with strings. And suppose I want to use the same deletion operator, hello, and minus minus. Suppose I want to remove this string, or so it will remove the last two characters, minus minus, so it will delete the last two characters and it will have that word hello. Suppose I'll perform this together. I want to delete this and I want to add I. What I'm doing, I'm deleting ELLO and adding I. Sorry, this has to be put in brackets first because the precedence will matter. So I'll add this in bracket and then add 1. So this should work. So it has deleted this characters and it has added I. Any doubts up till now? So then we have 10 minutes more. So we'll talk about expressions and pattern matching. So variables in Erlang. How do you define variables in Erlang? Now suppose I want to say sum equal to 100. Full stop. So variable begins with a capital letter. So assignment of a variable within Erlang is a one-time binding. Remember this. It is a one-time binding of the value to the variable. Now, if I try to change the value of sum in the further programming part, then this value is not going to change because 100 is already been assigned to this variable. So once you have bound the variable, you cannot change its value. That is what it means. Now this is very different to any other programming language. Like suppose I say sum is equal to 100 and 1. So it gives you exception error, no match or right hand side value 1001 because it tries to match this value with this value. So there's no match and it gives you the exception error, right? Now, limitations. What are the limitations of variables in Erlang? Now, suppose I want to change this. Suppose value is equal to sum plus. What answer will it give now? What answer should it give?
Two hundred.
So 200 is the answer. And can you assign values to two variables simultaneously? So Erlang gives you that facility of assigning values to two variables simultaneously. Suppose I have a and b as the two variables and I want to assign the values. So one is having 9 value and I can directly write this. Suppose I am performing a value is 9, b value is 45 and I am doing the addition of that. So that also simultaneously can be done. But this has to be put in round brackets. 9 plus 45 and suppose I have another tuple string suppose. So it adds also and it gives this value also. So it is um, in the evaluation what happens is if the pattern is a bound variable means to a variable to which a value is already assigned. So if the pattern is a bound variable or the element of the pattern is a bound variable, then the result of the pattern match becomes a comparison. and this allows for it's a more selective assignment that we can do in Erlang. Or suppose you want to get the name and email from a tuple, then we can use the pattern matching as, suppose I say contact name and suppose email. So I want to use this and is equal to contact comma me comma so it is just assigning values to two variables simultaneously. Now can you get the first two elements from the list and without touching the remainder of the list? Getting the first two elements of the list without touching the remainder of the list. Now suppose I define this one comma 2 comma 3 comma 4 comma 5 comma 6. So A comma and B dash pipe sign C is equal to that much of the list. So what is it going to get? Can you tell me why there is a exceptional error here? Why is it giving no match on the right hand side value of this is this? Why is it giving this error? Have you used A already somewhere? Have we used A somewhere? And have we assigned some value to A?
Yes, ma'am. We use.
So A is already 9 here, so it is throwing an exception, right? So let's use some other variables and see. Now will it give an error? Provided we have not used X, Y, Z somewhere. Okay, so what it is doing is X has been assigned the value 1. Okay, X has been assigned value 1, B has been assigned value, Y has been assigned value 2, and Z is the remainder of the list. Did you understand what we have done here? This is the head. So X corresponds to this value. Then this is, in this we have again, this is the head and this is the remaining part of the list. So Y is assigned value 2 and Z will be 3, 4, 5, 6. Or if we try to print the value of X, it is 1. Print the value of Y, it is 2. Print the value of Z, it is 3, 4, 5, 6. This is how it is doing it. Are you getting this? Okay, so next time maybe we'll start with functions and try to write some program.